All right, so we got problem 9.45. It tells us that the sinusoidal voltage source in the circuit is developing a voltage equal to 50 sine 400t. The problem is asking us to find the Thevenin voltage with respect to terminals A, B, and the Thevenin impedance with respect to terminals A, B, and then it wants us to draw the Thevenin equivalent. All right, so first off, we're going to go ahead and rewrite this. So we know this is 50 sine 400t is also represented as 50 cosine 400t minus 90. Oops, that's supposed to be the sine. Right? And so we can turn this into a phasor domain. So we can say 50e to the negative 90j. And this turns into such. So we can grab this portion of it, right? So we have 50, and we got cosine negative 90 plus negative j sine of 90 or negative 90. So this translates to this. Cosine of negative 90 is 0, and then the sine of negative 90 is minus 1. So minus 1 times j is negative j, so we result with negative 50j. So our source here can be represented by negative 50j. And then we can go ahead and do the equations for the capacitor and the inductor. So we can call the impedance of the inductor. We can, do the calculate the impedance for the capacitor and the inductor. Yeah. So the inductor, you can say 400 to negative 3 times 400j. So that would be 160j. And the impedance for the capacitor, we have negative j 31.25 e to negative 6 4 times 400, and that results in negative 80j. So you got negative 80j, and then we get 160j. All right. So we can go ahead and label our circuit. So we can call this negative 50j. Make this whole bottom portion our ground. And then we can call this V1, right? So I'm gonna do the KCL in blue. KCL, I1, I2, I3, right? I1 equals I2 plus I3, and then we do the equation for components, and we have the equation for components, right? I1 is negative 50j. I1, yeah, minus V1 over 320. I2 is equal to V1 over negative 80j. I3 is equal to V1 over 160j. And now we can plug this into maxima. So we have equations. I1 equals I2 plus I3. I1 equals 50 times J minus 1 over 220 to equal 1 over J. V equals V1 over 160 times J, then I1, I2, I3, and V1. Let's see. So yeah. So our V7 is or V1 essentially. I'm not gonna even can't snip it now. So V1 is -10. Yeah. So V1 is -10 minus 20J, and V1 is also our V7, right? So then now that we have our V7, we're done with the first part. Now the second part is find the Thevenin for impedance. So we get rid of this source, so we are left with something like this. Right? So 320, and we got -80J and then 160. So our Z Thevenin is going to be 320 in parallel with -80J, parallel with 160J. And I'm not going to do the math for that, but I'm going to tell you what it is. So it's going to be 64 minus 128J. And so now that we have our Thevenin impedance and our Thevenin voltage, we can draw this. So we can say it looks like this, right? And we have a function for Thevenin 64 minus 128J. So right off the bat, if we look at this, we know that this is a combination between a resistor and a capacitor. It could be represented as a combination between a resistor and a capacitor because we have a real and we have a negative that's imaginary. So yeah, this is the solution for 9.45.